Well, good morning, everyone. It's Thursday, June 22nd, 10 a.m. It's time for the long coffee break. My name is Andrew Tobin. I'm with Long, one of the sales engineers. Today, we are talking about rooftop air source heat pumps going all the way up to about 60 tons. We're lucky enough to have Dave Milligan with Innovent joining us. He's going to go through a nice presentation, kind of introducing us to Innovent's rooftop air source heat pumps. So Dave, go ahead and take it away.
Thank you very much, Andrew. Yeah, you mentioned, my name is Dave Milligan. I'm with the Innovent. I'm one of the regional sales managers for Innovent. Today, I'd really like to give you an introduction to Innovent real quick, and then really get into a quick hit on our air source heat pump product that we just introduced this year. So at first, Innovent, who are we? I view Innovent as a custom manufacturer, and custom means different for everybody. And the way I look at it is, Innovent for custom, we have the variable aspect ratio with our casing, so I can change my width and my height in 1-inch increments. And then I can put different components within the air tunnel based on what your application needs are. Whether it's, for example, what we're going to talk about today, an air source heat pump. If you're looking to put a humidifier grid in, if you're looking to do some type of energy recovery, that's all stuff we are very good at applying to our different equipment. The nice part about being a custom manufacturer, it gives you, the end user, the engineer, flexibility to meet whatever applications you're trying to get for. With our casing, for example, if you need to put a unit inside a building, we can easily make the unit height, width, whatever we need to fit through a doorway. We can chop it up into sections to bring it in. It gives us that flexibility with the design compared to a configurable type of a unit that's already pre-engineered, pre-designed, and they might not have that type of flexibility with their equipment. So that's all stuff that being a custom manufacturer gives us a lot of advantages to providing equipment to meet certain applications. Now, a little bit about our air source heat pump. This is something we've developed over the past year, really to address the push that we're seeing in the marketplace to go electrification, both in the Denver area, Colorado, out in the Pacific Northwest, and in certain cities along the East Coast. There's a push to remove a lot of the fossil fuels, to reduce the carbon that those type of equipment, those type of products put forth into the environment. And so we're seeing a lot of push to going towards an air source heat pump, for example, as an option. With our product, we're able to provide between 6 and 60 tons of cooling. It can range in 1 circuit all the way up to 4 circuits. And we're really able to top out around 20,000 CFM. The technologies that we are using is for example, the Copeland VFD compressor. That's going to be on every circuit. It's not just going to be on a lead circuit and then the others are staged. It's going to be, if you have 4 circuits, we're going to have 4 VFD compressors on each circuit. That gives us a lot more flexibility to ramping up and down, especially in the heating mode. We're utilizing the Zeolabig condenser fan. It's a quieter fan, gives us better performance. It also enables us to, if sound is an issue, these type of fans allow that reduced sound compared to a typical paddle type of condenser fan. And lastly, we have our own control systems. It is a Corel platform. And we're going to want to provide that so that we maintain all the safeties within this refrigeration system, especially when we're switching from heating to cooling modes. There's going to be some needs for defrost potentially, depending on your environment. And with that, we're going to want to make sure we do have all those controls with this equipment. And what we're seeing is, for air source heat pumps, we can go down to an ambient temperature of about 0 degrees. So that way we're getting good starts, stops, good heating operations with it. And then also another requirement is we want to make sure we have about 30 degrees and above coming to that AR coil or that DX coil / in the heating mode, it turns into a heater. we're going to want to make sure that we're having 30-degree air hitting that coil. What we've seen is that allows for really good operation of our equipment at that point. With this type of equipment, we are strongly recommending when your ambient temperature is below 45 degrees that you have some type of secondary heat. There's going to be a point where those air source heat pumps, those different circuits are going to have to go into a defrost mode. There's going to be potential frost or ice forming on the condensing coil. We're going to need to flip it back over to standard type of cooling to thaw out or remove that moisture and then come back in. It's those times when we're in those defrost mode that we're going to need some type of supplemental heat or backup heat to make sure we're still providing the right leaving air temperature going into the space. Okay, and those sources, I'll say it could be a direct fired burner, it can be an indirect fired burner, it could be hot water, it can be steam. Granted, those are all the fossil fuel types for the most part, but we do also have electric coils that we can put into these applications. And the electric heat coils really give us a wide range of flexibility with the ramping up and down with the SCCR controls. So those are all options that we can provide with this type of equipment. I talked a little bit about the defrost. Like I was mentioning, there's going to be needs when it's 45 degrees ambient outside air temperature and below, where with this being a cooling coil now, the condensing coil really being our cooling coil, that we could go to below 32 and we're going to start forming frost or ice on these condenser coils. It's these type of situations where, over time, we're going to have to flip and go back and defrost those coils. And so we're going to have to put the heat back into that coil. So that basically means that heat that we would normally be putting into the air tunnel to go down into the building is now going to be going back to that condenser coil. So that's why we need that extra heat, that auxiliary heat or secondary heat, but also to help mitigate that load. It's good where we can go multiple circuits. So having the ability to go up to 4 circuits on these refrigeration systems is a really good thing, because when it goes into that defrost, you're not losing 50% or 100%. You might be only losing 25% of your heating. And then that enables that secondary heat to be smaller and make up that difference. Also providing a lot of mitigation as far as with this electric heat. When we are in these defrost modes, we're providing the heat there. Another way to help with the making sure these things stay online is applying the unit with a return air, recirculating air, so that we're providing above that 30 degrees, hitting that cooling coil. So, or putting some type of preheater on there. And in our case with Innovent, applying some type of energy recovery to make sure that we're getting that 30 degrees or more onto that entering air temperature for the coil. The type of applications that we're seeing these being used for right now, I know definitely comfort cooling for heating, cooling type of applications, neutral air, DOAS type of equipment, definitely application for those. And then if you're just in a heating only type of an application, these are good options instead of using some type of direct fire burner or something along those lines. Where we're not seeing them being used for some type of process application, mission critical type of application where you require really tight temperature controls. The reason for that is when the units are in heating and you have to go into these defrost, you could have a little bit of a swing in temperature that might affect whatever you're doing in those type of processes. Another no-go for these type is if you're doing 100% outdoor air, because your temperature in outdoor air could drop below 30 degrees, that's going to affect the performance of them. The way to mitigate that is putting some type of preheater on there, or definitely with Innovent, applying some type of energy recovery type of system included in it. That would help prevent or be able to use it in 100% outdoor air type of application. Markets, really K through 12, higher education. We're seeing a lot of those being used in this type of application. Healthcare, hospitality, anywhere really where comfort cooling is a need, or type of DOAS type of equipment or dedicated outside air type of equipment is needed. So that's really where we're seeing these being applied in the marketplace. Just in summary, to hit, our capacities are anywhere from 6 to 60 tons for cooling. We want to make sure that the low limit for the ambient is not below 0 degrees. For mixed air temperatures, we want to make sure we're bringing back to the unit or back to the cooling coil 30 degrees and above when we're in a heating mode. Anytime we're 45 degrees or below, we're going to want a secondary heat source. Just because of the needs for going into a defrost cycle to help thaw out the coils. We can utilize these for the different type of applications with our E series, anything with an energy recovery system in it, or our C series, anything without an energy recovery type of a system. So that's really a wide breadth of product scope for us. I'd like to get in a little bit. I've talked a little bit about energy recovery. It's another type of technology that can go along with the air source heat pump and the electrification push that's going on in the marketplace right now. For us, about every 2 out of 3 units that we actually manufacture currently have some type of energy recovery component within it. I know codes and standards really require the energy recovery, but because of the energy recovery, it could have a very big role in the electrification push that's going on across the country. We offer a bunch of different types of energy recovery. This table gives a good synopsis or summary of what we can offer. We can do enthalpy wheels, enthalpy plates or cores. Those are devices that transfer not only sensible, but also latent. So you get some moisture carryover from one airstream to another. Those are typically a little bit higher as far as energy efficiencies or energy recovery devices are. You get into our flat plate heat exchanger, the runaround coils and the heat pipe. Those are a little bit lower efficiencies, but they're only sensible. We're not transferring moisture. But those type of systems are also pretty good in applications where you can't have cross-contamination of the supply air and the exhaust air to each other. So what I'd like to point out is, to us, what type of energy recovery device was used, we're agnostic to it. It doesn't matter to us. We just want to make sure that whatever device we're using is the right fit for the application that you have. Probably noticed I didn't really hit a little bit about that. The AccuBlock. AccuBlock is a new technology that we've been able to use over the past year. It's an ultra efficient, sensible latent device. It enables efficiencies up to 95% of the heat recovered, especially in colder climates is where we're seeing that type of application or this component really being used. You don't have to worry about it freezing or frosting up. So there's no defrost control for this AccuBlock. So it's a really interesting product that we have out on the market. And this is a video that kind of shows how the airstreams are going. You'll notice you have dampers on the front and leaving side, and in the middle you have this media, I'll call it, that you're basically heating up, charging, and then when you flip the airflows, you're then cooling that down, or the energy that's inside that media is being transferred to the other airstream. So those are some samples of what we can provide. I'd like to point out that if you're more interested in this AccuBlock, we're actually going to have a demo of this unit at the Long facility in Littleton from August 7th through the 9th or 10th. So you can come work with your Long salesperson, schedule an appointment. Maybe we can see you there and you can get a good look at the AccuBlock unit. It'll look very similar to here, where you'll see the media, you'll see the dampers, we'll be able to power it so you can see how it actually operates. Let me get this going. There we go. And in summary, and I'd like to point out again regarding our air source heat pump, 6 to 60 tons, down to about 0 degrees ambient, mixed air temperatures 30 degrees. If you're dealing with ambient temperatures lower than 30 degrees, you need some type of preheat or energy recovery for that product. In areas where we're going to go below about 45-degree ambient, we're going to want some type of secondary heat to help out when we're going into a defrost control for this equipment. And it's really good for comfort cooling, dedicated outdoor air type of systems. They're not an easy product to apply. We want to make sure at least it's not as easy as doing just a regular packaged air cooled type of a system. We want to make sure that it's the right fit for the right application. And that's where we can come in and we can really help go along with you, your long salesperson, to make sure that this product, the application is a good fit and it's a good design. So we can handle whatever potential issues that might crop up and be able to have a strategy to mitigate those items. Again, if you have any questions or comments, please reach out to your lawn salesperson. They'll be able to take those comments, work with them. If they can't answer them, they'll reach out to Innovent, to me, and we'll be able to supply you with some type of an answer. At this point, I'm going to throw it back over to Andrew and let him wrap things up here.
Dave, thank you so much. And I'm sure you all have a myriad of questions. That's a lot of information to try to pack into a 15-minute presentation. A lot of information there. Please, if you have questions, I've seen some on the chat line already, reach out to your log sales engineer. We'll definitely get all these questions answered for you. Definitely want to remind you all to join us next week. We have Mr. Travis Cowan. He's going to be talking about integrating heat pump chillers into your electrification designs with multi-stack. So again, another really good topic for our marketplace. And we thank you all for joining us on the coffee break, and we'll see you next week. Thank you.